This next lesson that we're about to do is about inverse functions, so taking it beyond just the trig functions. Hopefully at this point you understand that the opposite of multiplying is divide, the opposite of adding is to subtract, the opposite of x squared is the square root, the opposite of e to the x is the natural log, the opposite of sine is the inverse sine, and so forth. And the truth is, when we're talking about inverse functions, the difference is instead of just thinking of it as operations, the opposite of adding is to subtract, it's actually looking at a function. So 2x, the opposite or the inverse function, would be x over 2. Now what I want you to notice about functions, and inverse functions in particular, is what this basically means is, if I was to take this inverse function and put it in place of x, so I would have 2, and in place of x, I would put the inverse function, that what should happen every time is I should be able to get the same result no matter what the functions are that I'm dealing with. Every single time, if I take the inverse function and put it in place of that x, what do you notice? What do you get every single time? Every time you get x. And that is, truthfully, the rule. If I take the inverse function and plug it in for x, you should get x. Let me just show you again. So I'm looking at just the first couple here that I just did on the other page. Let's look at this last one here. The cube root of x cubed. In essence, they cancel each other out, leaving with just x to the first power. If you look at it with a fraction exponent, it's a little bit more obvious, I think, because instead of looking at it as cube root, you can see it as to the 1/3. That's the same idea, right? Remember that from last chapter? So you can see, oh, we multiply those exponents. That would be 3 over 3, which is x to the 1, and it becomes even more obvious that that's x to the first power. So if I want you to find the inverse function given a function, that becomes a little bit tricky. And if I was to give you the steps of this, and I'm sure you've seen this before, there is one major step to this. The first thing that you're going to do is set the function equal to y. Now this seems kind of a silly little step, because the truth is, I mean, it's already, just written in a form. Okay, so it's y equals. What difference does it make if you change a letter? Well, good. I'm glad you say that. But the next step, it factors in. So the next step, what you want to do is you want to switch the x and y. And some of you might be able to group these two steps together. Let me show you what I mean here. So we have y equals 3x. That's the first thing. I'm going to set it equal to y. Then the second step, that's step number 1. Step number 2 is I am going to now switch the x and the y around. So I have x equals 3y. Do you see what I mean by switch x and y? We're going to switch them around. Everything else is going to stay put. Then step number 3. Step number 3 is we're going to solve for y. And so now when I solve for y, I'm going to divide this by 3. Divide by 3. I get y equals x over 3. And that would mean that this is the inverse function of 3x. So the way this would be written is the inverse function would equal inverse of x would equal x over 3. And that would be as it would be written. So let's try another one. Step number 1, set it equal to y. Step number 2, switch x and y. What's step 3? Good, solve. So now what's the first thing that I'm going to do? I hope you're saying, we're going to subtract that too, Mrs. Madison. And then what am I going to do? Divide by 3. And so this is gone. So I have y, or rather the inverse function, is equal to x minus 2 over 3. Notice that the whole thing gets divided by 3 because that whole thing was over there on the left side when I divided. So be very careful about that, making sure those lines extend all that they're supposed to. All right, let's do the next one. Okay, so first thing, set it equal to y. Second step, switch the x and the y. Third step, what are we going to do? Good, you're going to multiply both sides by that 3. Uh-oh. Now what am I going to do? How am I going to get rid of that sign? Because I want y alone. What is the opposite? What is the inverse of sine? Good. Inverse sine. And so I would do the inverse sine of both sides, leaving you with my inverse function of x being the inverse sine of 3x. It may not be pretty, but that's the answer that we're looking for there, and that would be the inverse function of that. Next one, set it equal to y. Switch the x and the y around. Solve for y. What's the first step? Yeah. All you gotta do is yeah. All right, now what are we gonna do? Good, you're gonna add that one. Pretty simple step after that, isn't it? Now, here's the question though. Here's my inverse function. We got that. Is the plus one up in the exponent or down in the base? It is down in the base because we did the e first. So only the x was over there at the time that we e'd it, right? Great. All right, now let's see how we can apply this a little bit more. The first part of this question says f of x equals x minus 3 over 2. First, I want you to find f of 1. So what I'd like you to do right now, pause the video, I'd like you to find f of 1, and then for b, find f of 7. See that you get both the answers. And I will actually do them myself and have the answers up here. I'm even going to talk you through it. So if some of you are thinking, I don't know how to do that, think back to our video from the day before. So go ahead and pause that. Great. All right, hopefully at this point you're coming back to me and you're looking at how to do this question. We're going to take f of 1. That means that in place of x, I'm going to put 1. So I have f of 1 would be 1 minus 3 over 2. So that's negative 2 over 2, or good. F of 7 would be very similar, except we put 7 in that spot with the x. And so I'd have 4 over 2, which is 2. Hopefully that was a pretty simple task for you. Now C is a little bit different question because it's saying the inverse of 3. Now, as I've been saying throughout this unit, the one thing I want you to understand about inverse is it's like Jeopardy. I'm giving you the answer. So one approach to this actually could be, here's one approach. One approach is to understand what this is saying here is that minus 3 divided by 2 equals 3. I want to know when will this function equal 3. So one approach is to take the function that you already have and solve it because we know what the answer is and we just want to know when that occurs. That is the crux of inverses. And so what would you do first? I want you to think through this process. What was the first thing you do? The first thing you do is multiply both sides by 2, correct? And so I would be left with x minus 3 because the 2's to divide out on this side equals 6. And then what would you do? Good, you would add the 3 and you would get x equals 9. Now let me show you another approach, okay? Another approach. Another approach is we're going to find the inverse function. So we understand that f of x, or y, equals x minus 3 over 2. Second step is to do what? Switch the x and the y around. So I would have x equals y minus 3 over 2. Tell me, please, what's the first step you're going to do? No, we're going to multiply by 2. So I would have 2x equals, again, we multiply by 2, so that 2 would cancel out here. We'd have y minus 3 on this side. And then what would I do? Add 3. Doesn't that sound familiar to you? So what I would have then is 2x plus 3 equals y. And then when the question says, oh, I want you to do the inverse of 3, this is my inverse function, right? And so all I would need to do is plug 3 in there. So 2 times 3 plus 3, what do you get? 9. This is no coincidence that these are exactly the same. And again, do you notice these processes were the same? This is the one here that we have at the bottom is just a more general approach. So that if they ask me repeated questions of inverses, what if now I asked you for the inverse of 5? What would you do? Well, we have the inverse function solved for me right here, right? And so all I would need to do is say, oh, well, that would just mean I'm going to do 2 times 5 plus 3. And so I would do 10 plus 3. Where many of you would have instead every single time kept solving the original equation equal to 5. And that's fine, but it's just a longer process than needs to be. So So all I'm saying is that the inverse function is useful, especially if we don't know how to solve it otherwise, if we don't know how to approach it when we have a number. And so it makes it a little bit nicer to look at and move in a more general sense. So that is inverse functions. Hopefully these practices were helpful, and tomorrow we'll be working on them in class.